Let's take a look at the derivative specifically as a limit so that we can help understand what is going on here. So let's say we have a function. I don't know what it looks like, so let's just say it looks like this. And I want to find what is the slope of the function at a given point, say right here. Well, the slope of that would be the slope of this line. I could zoom in real close and that line would look flat. I want to find the slope of that line. So what I'm going to do is I'm going to say, okay, here's a point x. That's where I want to find the slope of the line, right? Let's extend that out. That's what I want to find. I'm going to approximate it by going a little further. How about I go over to another point over here? Let's say I go a distance of h away. So if that point was x, this point is x plus h. So that means right here, this is going to be f of x, and this is going to be f of x plus h. So now if I wanted to find the slope of the lines between them, between these 2 points, that's just going to be f of x plus h minus f of x. And then we divide by the distance of h. That's change in y over change in x. And that's basically all the difference quotient is. Do you see the similarities here between the difference quotient, the derivative, and just the simple difference quotient? The only difference here is if I were to take an h value that's like the one I showed, this is kind of far off. See, the slope of that dashed line is very off from the slope of the red line. But if I were to take an h value really close, like say right here, well, then I'm going to get a slope that is pretty much the same as the slope of the red line. So by taking the limit as h approaches 0 of that point, or of this slope equation, we can find the derivative. And that is what this is. If you like this video, be sure to like the video and subscribe to the channel. That way you don't miss out on any more helpful tips.